Okay, a longer example using halving the interval and Newton's method and the quadratic formula to try and find these roots. So the equation is f of x equals 2x squared plus x minus 2 equals 0, so that's where the root is, has a root between 0 and 1. So show the question. So f of 0 and f of 1, and we expect them to be different signs, in which case it would be a root. So that's minus 2, and that's 2 plus 1 minus 2, which is 1. So that's less than 0, that's positive root 0, that's positive. So therefore a root exists between x equals 0 and 1. Part B. Use the method of halving the interval twice. Alright, well once is a half. So I like just to draw a little graph somewhere here. So we know it's in between 0 and 1 and we've halved it. We have to see which section we want. So f of a half, I'll do it underneath, is 2 by a half squared plus a half minus 2, which is a quarter. So a half plus a half is 1, minus 2 is minus 1, so it's less than 0. So if we just draw a quick plot, 0 is minus 2, I'll actually do that. 0 is minus 2, and 1 was 1, a bit closer, and a half was minus 1. So about there. Okay, so therefore there's no root in between there. One's a minus and one's a plus. So now we're going to halve it again, and that's going to be at 3/4. Part B. So f of 3/4 equals 2 by 3/4 squared plus 3/4 minus 2 minus the 2. So I don't have a calculator on me, but we can figure out if it's plus or minus. So that's 9 on 16, so that's 18 on 16 plus 3/4 minus 2. Get a common denominator. So that's 18 plus 12 minus 32. That's 30, so that's negative 1/8. So that's less than 0. So negative 1/8 at 3/4 is there. So we're going to scrub that out. So we've found that a root exists between 3/4 and 1. So that's halving the interval. And then next bit, C. Use Newton's method once to find an approximation to this root of the equation, correct to 1 decimal place. Now this time they don't actually tell us what value to take to approximate it, but knowing from part 1 that the root is somewhere between 3/4 and 1, at 1 the value of y is 1, and at 3/4 the value is minus 1/8, so that's closer to the axis. So I'm going to take x equals 3/4. That's going to be my a value. So we need f of 3/4. Well, we already found that, that's minus 1/8. And we need to find f dash x first, and then sub in 3/4. 4x plus 1. And if I sub in 3/4, 4 by 3/4 plus 1, that's 4. So Newton's method, the approximation, It's A1, the new approximation, equals the first approximation minus f of A on f dash A. So it was 3/4 minus f of 3/4 was minus an eighth. F dash of A was 4. So it's 3/4 plus 1 on 32, which is 8. 24 plus 1. So 25 on 32 is our new root, our new approximation to the root. So if you compare that to 3/4, 1/4 of 32 is 8, so 3/4 is 24 on 32, and we've approximated it at 25 on 32, so very close. And the last question is use the quadratic formula to try and solve it. So it's 2x squared plus x minus 2 equals 0. So the quadratic formula says x equals minus b plus or minus the square root of b squared minus 4 a plus c over 2a, which is 4. So x equals minus 1 plus 1 plus 8/16 over 4, which is minus 1 plus or minus root 17 on 4. And if we have a look what they are as decimal approximations, so we've got 25 on 32 for Newton's method. Let's have a look what the decimal approximations of those two roots are. We're obviously only finding one of them. So the decimal approximations, as you can see there, this is the root we're looking at between 0 and 1. 0.78077, all that in exact form. And 25 on 32 that we achieve from Newton's method is 0.78125. So, we're in the thousandths now, and it's exceedingly close. Okay, so 3 different ways of finding the root. Well,